Hello there and welcome to my, I don't know what this is, a discussion. So today I am going to walk through the process of generating 3 different types of visualizations in R. I already have my code written, so we're just going to run through these line by line. A couple things that I have going on here in my environment is that I'm running R, the 4.0 version. I'm in a project called DataViz, and my code is saved as R graph assignment. So the first thing that I need to do in order to begin running my code is I need to kind of activate the packages that are required for this. So to do that, I'm going to use the command library here with the name of the package that is already installed on my computer. So there would be an extra step if I did not have these installed. And I'm also going to activate the package ggplot2. So now down here on my console, it just shows me that those have been run. They're activated. I don't need to verify that in any way. I'm confident that it's there. The next thing that I'm going to do is that I am going to use this read Excel package in order to read an Excel file that I have data in. This is the function or command that I'm going to use, and here in quotations is the directory where my data lives. And I am going to push all of this data by using this arrow and dash to an object called sp /data. And that's just for my convenience so that I don't have to type out this whole long thing every time that I want to call my data. So I'm just going to run this. You see that here in my environment, I now have a data object with 90 observations of 2 variables. If I wanted to view that, I could just click on it and it's going to show me that the data is indeed loaded in 2 columns, variable 1, variable 2, and I have 90 observations. Next, I'm going to create a scatter plot using the command or the function of ggplot. ggplot is in this package, ggplot2. So the first argument of ggplot is the data argument, and so I'm going to use sp /data for the data that I just loaded up here. Next are the aesthetic commands argument, which is going to be my x variable is I'm using v2, and my y variable I'm using v1. I'm going to go ahead and close those parentheses, and then I'm going to start adding a layer or more layers in my ggplot by using this plus sign. So on the next line, my next layer is going to be the type of point for my scatter plot. And so I'm going to use geom/point, and the shape that I want personally is 17, and that shape is a black diamond. I'm going to use another plus sign because I want to do something else with my ggplot, which is add a title. For that, I'm going to use the function ggtitle, and in quotations, I am going to title my scatter plot that employee performance by hours of training. I'm adding one more layer with another plus sign. Well, 2 more layers technically because I have another plus sign here. And I'm going to change the X label and the Y label. So my X label in quotations is production rate in pieces, and the Y label is training in hours. So all of these items right here, well, not really, all of these items right here constitute my scatter plot, and I'm going to run these. And so here down in my plot corner, I have employee performance by hours of training, production rate in pieces. This scale starts at 120 to 200. R, I think, automatically does that. It doesn't start from 0. R automatically does that to fit all the data in the plot, and then training and hours. And in this scenario, I have, I'm a consultant with a client that's asked me to work on some different training to improve employee performance. And this was getting a baseline of the hours in training and what the employees are producing at this time. And I really feel like that this is not very linear, is not giving me a whole bunch of information. Because everything is all over the place. So there definitely might be some something else impacting production and training in here. And that should be investigated. Okay, on to the next one. Now I'm going to make a density plot, but I didn't have any data for a density plot. So the first thing that I need to do is generate some data. My first command in order to generate data is to set a seed, and I'm using 1, 2, 3, 4. You can use anything that you want to when you set a seed in between these parentheses. I'm using 1, 2, 3, 4. The purpose of this value is just so if anybody else comes to run this code or wants to use this code and get the same values that I did, they need to use the same seed in order to get the same type of distribution that I did. Next, I'm going to create an object called density data that's going to hold the data that I'm getting ready to generate. So I'm creating a data frame by using data.frame. And I want to have 2 variables. So the first variable I'm going to call the treatment variable, and it's going to equal a factor that is of low, medium, and high with 200 variables each. So 600 variables total with 200 in the low, medium, and high categories each. Then I have a comma here, so I'm not done. Now my next column in my data frame is going to be the score. And I'm using the round command so that this means I'll have 0 decimal spaces. You know, it's gonna round the variables. So this R norm just means that I'm generating like a vector of normally distributed random variables. So I want 200 where the mean is equal to 55, but the standard deviation is 5. I use a comma because I'm making I'm making 3 distributions of variables so that they're not like all equal. Then I'm making 200 with a mean of 65 and a standard deviation of 5, and 200 with a mean of 95 and a standard deviation of 5. And so this is going to go along with my low, medium, and high factors. All of this together creates my data. Oops. I had to do that again because I didn't equal this. Here we go. Unexpected error. Now I have my SP data here, and I can look at it, and it seems like it did not work out. Oh, density data. I'm so dumb. Okay, here we go. Here is my density data. Low, medium, and high. I had to think about that for a minute. Okay, onto my density plot. I'm going to use ggplot again. I'm calling my density data. My aesthetic is going to be score on the x-axis, which is these numbers, and because this is a density plot, density is automatically going to be on my y-axis, but I want to use another argument for this because I want all 3 trainings in one chart. So I'm going to use this color treatment, and that's going to distinguish each density curve by color for each low, medium, and high factor. Then geom bottom slash density is the function that I'm going to use that creates the density plot. Then that's opposed to the geom bottom slash point that I used for the scatter plot. Then I'm going to continue to add layers with these plus signs again with the title of density of scores by treatment. My X label is scores and my Y label is density of treatment. I'm going to go ahead and run those. And so now I have a legend here with medium, low, and high. Density of scores by treatment. Here are the scores of a training evaluation for each different type of training. The treatments are the training and the density of treatments. And so the green represents the low treatment. The medium here is represented by blue, and the red is represented, the high is represented by red. Finally, I have bar data. Finally, I'm making a bar graph. And I'm going to load some new data for this. I'm going to use read Excel function again. This is the location of my data, and I'm going to save it to an object called bar data. So here we have the bar data. It's 4 observations of 2 variables. And then I'm going to create a new plot using ggplot once more. The first argument, again, is the data, bar data. Then is the aesthetic. So X is good. This time X, the aesthetic can take more than 2 arguments, but for this I'm just using the X and the Y argument. So X is going to be time, Y is going to be treatment, and then I'm going to continue with the layers. So here I'm using the geom bottom slash bar as opposed to density or point as I did for the scatter plot. And I'm going to use an argument here, which I didn't use one up here for density, but for the bar I do, because you can have the bar focus on different types of statistics for what it plots, and I want it to just I want it to use the data as it reads in the actual data set. So I'm going to use stat is equal to identity here. I'm just going to leave the data as it is. The next layers that I'm going to use are going to be the title, the X label, and the Y label, all in quotations, being effectiveness of training on completion time. The X label is time to complete task in minutes, and the Y label is the training treatments. So I'm going to go ahead and run those, and I get this horizontal treatment of time to complete the task in minutes with the different training treatments. So these are 4 interventions of new types of training, and the purpose is to complete a task in the shortest amount of time so that production can go up. And so it looks like here that the training that is labeled that is represented by T1 is having people understand and be able to complete the task in less time. So that bodes pretty good for the client. Thank you very much, and that is all I have.